All right, today we're talking about an AI that's done something, well, something a lot of people thought was pretty much impossible. It's not just solving problems, it's showing a kind of mathematical creativity that we've always thought was uniquely human.
And really, it all comes down to this one big question, right? Can a machine actually have a spark of genius? For the longest time, the answer seemed like a pretty firm no. But this new AI AlphaGeometry is making us rethink, well, everything. So, what's the big news? Get this. For the very first time, an AI has performed at the level of a gold medalist in the International Mathematical Olympiad. And if you don't know, that is the world's toughest, most prestigious math competition for high schoolers. This is a huge deal.
Okay, and this chart really shows you just how big a deal it is. So look at this. The best any AI had done before this was solving what? About 10 of these problems. AlphaGeometry? It solved 25. And as you can see, that puts it right up there, shoulder to shoulder, with human gold medal winners. We're not talking about a small step forward here. This is a giant leap. So what this really means is that a huge, long-standing gap between AI and human reasoning, it's just been closed. This is one for the history books, showing that a machine can actually tackle problems that need deep, creative, out-of-the-box thinking. But to really, really get why this is so amazing, you have to understand just how hard these problems are. For an AI, solving Olympiad-level geometry, it's been like trying to climb Everest without oxygen. These Olympiad problems, they're not about just crunching numbers. Not at all. Solving them takes pure ingenuity. I mean, you're dealing with a practically infinite number of ways you could even start the problem. So you can't just brute force it. You need intuition, you need that aha moment, that creative spark to find the elegant solution. And this is exactly where AI has always stumbled. Until now. So you're probably asking, how did they do it? What's the secret sauce? Well, the answer is this brilliant design that, honestly, you can think of it as an AI with two brains, both working together in perfect harmony. And this slide just illustrates that perfectly. On one side, you've got this neural language model. Let's call it the creative artist. It's super fast, it's great at spotting patterns, and it's always throwing out these intuitive, promising ideas on what to do next. But, artists can be a little messy. And that's where the second brain comes in, the symbolic deduction engine. This is the rigorous fact checker. It takes every single creative idea from the artist and just grinds it through cold, hard logic, making absolutely sure every step is 100% mathematically sound. And it's this amazing tag team, this back and forth between intuition and logic that lets AlphaGeometry navigate that infinite ocean of possibilities without getting lost. It's creative, yeah, but it's also completely, flawlessly logical. So how in the world did it get so smart? How did it develop that kind of intuition? This, to me, is maybe the most mind-blowing part. It wasn't fed a bunch of human-solved problems. No. Instead, this AI taught itself. It generated and then solved 100 million unique geometry problems from scratch. It basically wrote its own textbook and then mastered it. And all of this brings us to what might be the most important point of all. AlphaGeometry isn't just spitting out the right answer. It's how it gets there that really shows that spark of genuine creativity. And this is so critical. Its solutions aren't some kind of magical, unreadable black box output. AlphaGeometry creates proofs that actual human mathematicians can read, understand, and check. It explains itself. That's a massive deal for any kind of future collaboration between humans and AI. Okay, but this is the part that honestly gives me goosebumps. When it was given this notoriously difficult problem from the 2004 Olympiad, AlphaGeometry didn't just solve it. Nope. It actually discovered a new, more powerful, more general version of the theorem behind it. Now, that's not just solving a puzzle. That is creating brand new mathematical knowledge. So, okay, this is all incredibly cool for math nerds, but why should you care? Why does this matter? Because the ripples from this go way, way beyond just math competitions. This kind of AI reasoning could be the key that unlocks the next big scientific revolution. Just think about it for a second. Imagine using this kind of AI to speed up discoveries in physics or chemistry or medicine. Or what about in education? Imagine AI tutors that can walk a student through a super complex problem step by step with perfect clarity. This tech could totally transform how we learn and how we discover new things. And hey, if you're still not completely blown away, don't take my word for it. Listen to this. This is a quote from No Bao. He's a Fields medalist. That's basically the Nobel Prize for math, so he knows what he's talking about. He said, "I still find it stunning that they could make it work." When one of the greatest mathematical minds on the planet is stunned, you know you're looking at something special. We might just be standing at the dawn of a whole new era, one where human and AI minds work together to push the frontiers of knowledge further than we ever thought possible.